Okay, welcome to 4.3. We're in the middle now of the chapter where we are focused on linear equations and inequalities in two variables, and we've been practicing some graphing. In fact, that's our goal, is to become expert graphers of lines and back and forth, from the line to the graph to the line. And one of the pieces that we're going to need to be able to continue our pursuit of a real elegant, efficient way of graphing is this concept of slope. So far, what we've done is to work from the equation. So far, we've gone from the equation trying to graph the line. And we had two ways of doing that so far. In 4.1, we used a table of 5 values that we picked for x, plugged them in, found our y values, connected the dots, created the line. Exhausting, time-consuming, but a good exercise in how points go together to create a line. I'm going to adjust this just a little bit so it's a little bit easier to work with. Okay. And then in 4.2, we tried to make that a little bit more efficient of a process, as well as picking easy numbers to plug in. And so we went with the intercept method, where we let x equals 0, find y, and then we let y equals 0, find x. And that was lovely because 2 points, we've got our line, 0 is easy to plug in. We did hit a few snags along the way when it was a horizontal or vertical line and there weren't 2 intercepts, or the situation where it might have just 1 intercept passing through the origin, and so we still had to come up with a third point or memorize what type of line in terms of vertical or horizontal. Which is fine. The vertical and horizontal, that piece will still stay that way. You're just going to have to get used to and get comfortable with recognizing when you've got a horizontal and vertical. But for these other ones, there still is a method that'll get you a little faster, and you don't even have to bother with plugging in points. And remember, the reason we're doing all this, the reason we're pursuing this, is because our goal is to become experts, or an expert, in graphing linear equations, creating the line from an equation, recognizing that it's linear, and creating the graph, the line on the page that the equation represents. Now, when I say expert, what I mean is that you would know it forwards and backwards. So being an expert means knowing it forwards and backwards. So far we've been focused from the equation to the graph, so now we're going to do the reverse of that, where we focus from the graph to the equation. We're going to add that piece in. I'm sorry, did I say it right? From the graph to the equation. Okay. Now, I just want to take a little side detour over here. Earlier in the sections, we talked about what types of equations of a line there are. There was the formal, the friend, and the fallback. The formal, the standard version, the ax plus by is equal to c. There was it's officially known as standard. I call it formal. There's the friend version, y equals mx plus b. The official name of that is slope-intercept form of the equation. And then there's also what I call the fallback plan, and that is, it looks a little bit more messy. Y minus y1 is equal to m times x minus x1. This is known as point slope form of the equation. So there's standard form, slope-intercept, and point slope. I call it the formal, the friend, and the fallback. Our goal in graphing is to move from the table of 5 values to the intercepts. We've done that. And then from intercepts to what I call instant graphing, which is where you'll feel like an expert in graphing lines. It requires the use of this slope-intercept form. Well, we've already kind of investigated intercepts in the last section, so before we can move on to our next level of expert graphing, we need to investigate this idea of slope. And so that's what we're doing here in 4.3, is to grab another piece of the information so that we're becoming expert graphers. So let's talk just a little bit about what makes a line as we start to investigate this idea of slope. So a line itself, if you had to define it, is the collection or the set of points that it goes through. So if you have several points, you can connect them, you create the line that they go through. Now, those are not the only points on the line. There's an infinite number of points that make up that line. We could never list or count them all because numbers can go very small, very big. They can be numbers in between numbers with decimals and fractions. So there's just an infinite number of points that make the line. And that's kind of where that method of the table value was born from. And the intercepts was born from the idea of, hey, we don't really need all these points. Really, a line can be drawn through two strategic points. So just drawn through 2 points. And in 4.2 we tried to pick strategic ones, which is a way to say easy ones, ones that will be beneficial to us. We used intercepts for that, where they cross the x and y axis. And those are easier because of the putting in x for 0, or putting in 0 for x, then you turn around and put 0 in for y. Those give you your intercepts. Now, what we're going to start to investigate today is yet another concept. If we knew a starting or beginning point on the line and how it moves from that point. In other words, if we had a particular point that we knew of that was on a line and we knew how it moved to the next point, we could create any 2 points. We wouldn't necessarily need the intercepts, and we could connect those, and that would create our line for us. Okay, so now we're not going to confine ourselves anymore to intercepts. We're looking to see if we can just find any old point, a point to begin with, and then how it moves forward from that point. Then you would have 2 points, and you could connect and create the line that way. So that concept of being able to move from one point to the other is what slope is. Okay, so slope is the line's movement from one point to another. It also can be referred to as the steepness or the slant of a line. And it really doesn't matter which 2 points you have. These two that I kind of highlighted in black here to talk about the movement, that ratio of the movement, the way that's going to be described, would be the same way we would describe the movement from any 2 points along that line. That's what makes slope such a useful tool in linear equations, is because no matter which 2 points you pick on the line, you're going to get the same slope relationship, the same steepness, the same movement, ratio of movement from one point to another. Okay, so we'll continue that talk about the ratio in the bottom part of this page in the next video. Good job.